So one of the important points of the stretch reflex is that you get a response in the muscle that was stretched. Okay? So it's not unusual, but that's one of its features. Okay, so I get one muscle that's stretched. The muscle that's stretched is the one that ends up contracting. Okay, and there's some words for that, and we're not going to worry about that. Another feature of the stretch reflex is that it's known as a monosynaptic reflex. So what does that mean? Right. So monosynaptic, meaning one. So you have one synapse. All right. So the information comes in from the spindle, synapses directly onto the alpha motor neurons, and goes right out to the extrafusal fibers, causing contraction. Okay. So if it's a monosynaptic reflex, what does that tell you about the speed of the reflex? Is it a slow reflex, or is that going to be a fast reflex? Right. Because there's only one synapse, there's very little time spent at the integration stage here in the central nervous system or in the spinal cord, so you have an extremely rapid reflex. Okay, and that's because there's only one synapse. So does anybody know, if you tap me on the leg, how long from the time that you tap me or stretch the muscles until I'm going to get a neuromuscular response? Meaning I'm going to generate action potentials in my leg. Does anybody have any idea what the latency of that would be? Okay, maybe we should back up. The latency is from the time of a stimulus until the time of a response. Okay, so because we're going to talk about latency a little bit more, a few times this semester. So latency is from the time of a stimulus until the time of a response. Okay, and this happens to be an involuntary response. We talked about latency relative to reaction time previously, where I had, let's say, a visual stimulus, and then I had to make a reaction. So there's a latency associated with the reaction time measure. In this case, we're talking about a latency between when a muscle is stretched and when we get contraction. Yes?
Wouldn't it be less than a reaction time? Because...
Good. So she said, wouldn't it be less than a reaction time? So that's one really good point. Reaction time is considered a voluntary response where I had to make a decision and say, okay, lift my finger off the key. And what did we say was kind of a minimum time for a reaction time to a visual stimulus? All right, so we said about 0.2 or 200 milliseconds from the time I receive a stimulus or a stimulus is initiated and then when I actually make a reaction. And that'd be an example where I was hearing the light came on, I lifted my finger off a key. So about the fastest we can do that is 200 milliseconds. Okay, so what would be the late, and there's a lot of obviously cognitive processing going on. I'm doing stuff here up in my brain and I have to make a decision. I want to lift this finger off and send action potentials down my spinal cord and then out to the muscles. So a lot of things have to happen physiologically for us to have a voluntary response. Okay, we just talked about stretch reflex as an involuntary response that only has one synapse. So there's not a lot of thinking going on in that sense, or a lot of integrating in the spinal cord. That information goes right in, synapse and alpha motor neurons goes right back out to the extrafusal fibers. Okay, so at the knee, if you tap me on the knee, probably an average latency is about 30 milliseconds from the time you tap that tendon at the knee until I get a response or generate electrical activity in the muscles. Okay, so stretch reflex have latencies in the lower limbs of about 30 milliseconds. So that's really fast. Okay, that's fast. Okay, because perceptually reaction times seem very fast to us. Like 200 milliseconds is just no time at all. But 0.03 seconds or 30 milliseconds is extraordinarily fast. And they're fast because there's only one synapse. Okay, information goes in and goes right back out. So what happens if you tap me on the elbow and generate a stretch reflex in the tricep? Okay, or chop me on the bicep and I do this. What do you think the latency would be for those upper limb stretch reflexes? Have you been in this class before? So he said 20. Okay, so 20 milliseconds for upper limb stretch reflexes. Well, he's in fact correct. Okay, so why would that be? Why would there be a difference in latency? There's still just a single synapse between sensory input and the motor output.
Shorter pathway?
Right. So you have what? Shorter pathway. It gets into the information gets into the spinal cord faster. Okay? That makes sense? I mean, there's physically less distance for that action potential to travel. And since there's still only a single synapse, then you have a shorter latency. Okay, so it's just purely a function of the distance the information has to travel on our nerve tracks. So different parts of the body will have different latencies, even though all your stretch reflexes are monosynaptic or a single synapse.